So we will start doing review problems on chapter 12. Just 1 second, I want to download it because I can do for you comments on it. One second. It seems that I have two PDFs of same name, so I will. Okay, so we will start by the first problem. Car A starts from rest at t equals 0 and travels along a straight road with a constant acceleration of 6 feet per second square until it will reach a speed of 80 feet per second. Afterwards, it will maintain the speed. Also, when t is equal to 0, car B located 6,000 feet down the road is traveling towards A at a constant speed of 60 feet per second. Determine the distance traveled by car A when they pass each other. So, in any problem like this, okay, try to do a small scheme that can help you in your analysis. So, for A, we have two phases for A, okay? It's at t equals 0, it will start a motion with constant acceleration. So, I have a certain phase 1, of constant acceleration, which is equal to 6 feet per second square. Then, when I reach a velocity of 80 feet per second, I will maintain my constant speed and go through a second phase. So for A, you should divide your calculation in two phases, phase 1 and phase 2. Okay, so this is motion of A. It's divided into two phases. Okay, while for B is moving to the left in the opposite direction, and it's moving at constant velocity at a speed of 60 feet per second. So for A, I have two phases. For B, I have just one phase. And the distance between the two is given. Okay? Now, when they say determine the distance traveled by A when they pass each other. So what is the meaning that they will pass each other? Who can tell me?
They will meet at a certain point on the road.
Very good. They will meet at a certain point. So the coordinate of A will be equal to the coordinate of B. So what we should do first, one of the methods is to say, I will find coordinate of A function of time. I will find coordinate of B function of time and say that SA is equal to SB. Okay? A second method is to say, if they will meet, this means what? This means that the distance traveled by A plus the distance traveled by B is equal to what? To the total distance separating A and B at the initial state, which is equal to 6,000. Okay? So now we will find the coordinates of A and B. To do this, we will start by A first. For A, you should pay attention that you have two phases. So you should find equation of phase 1 and you should find equation of phase 2. So let's start first by phase 1. Now, why it's important to get phase 1? Why I don't start immediately by phase 2? Because they will meet during the second phase. So why do I need phase 1? Who can tell me?
Because we have to calculate during everything for the position.
Because each phase need boundary conditions.
Total distance traveled.
Yes, and what is the boundary condition for phase 2? Boundary condition for phase 2 is the end of phase 1. So I should find what are the conditions at this point here. Because if I don't know what is the velocity here and what is the distance traveled until reaching this point, I cannot know the properties of the second phase, because the end of phase 1 will be the beginning of phase 2. So I will use properties at this point as boundary condition for phase 2. Okay? This is why I should start from doing analysis of phase 1. Now, during phase 1, they said that the velocity is 80 feet per second. Okay, sorry, they said that the acceleration is constant. When you have constant acceleration, this means that you can use the equation of constant acceleration, which is v equals to v0 plus constant acceleration times t. Okay? Now, at the end of this phase, the velocity will reach which value? At the end of this phase, the velocity will reach v equal to 80 feet per second. So this is a boundary condition for phase 1. Okay? Now to find the total time of phase 1, I just replace v by 80. Okay? And I know the acceleration. The acceleration is given, and the initial velocity is 0 because it's starting from rest. So I can, the only unknown in this equation is time. So I can find time of the first. Okay? So the time I found here is for phase 1. So at the end of phase 1 here, the time is 13.33 seconds. Okay? Now, this is an important thing. So first, I know the time at this phase. Second, what is the velocity at this point? I know it. It's 80 feet per second. And it will remain constant during phase 2, because they said that once I reach this velocity, I will maintain it for the remaining motion of A. Okay? So I still need only to find what? To find the distance traveled during the first phase, because I will need it as boundary condition for the second phase. To find the distance traveled during phase 1, I will apply the relation for position. Relation between velocity, position, and acceleration for constant acceleration. Okay? Now here you have two possibilities. Because you already have the time t, you can apply s equal to half at squared plus v0 t plus s0. Or you can apply v square equal v0 squared plus 2a delta s. Both will give you same result. Okay? So this formula will give you directly what is the value of S1, because considering that at initial state S0 is 0, so we can get S1, which is the coordinate of this point. Okay? So now I know all conditions at this point. I know that at this point t is equal to 13.33, s is equal to 533.33, and velocity is 80. Okay? Now, for the second phase, now I want to write equations for the second phase. For the second phase, it's constant velocity, okay? But I should pay attention for the initial condition. The second phase is not starting at t equals 0. It's starting at t equals to 13.33. So when I want to write the equation of S for phase 2, S2 is V times delta t plus S0. Plus S1 if you want here. I will try to explain for you why they did this, and if you don't understand, we can go back to integration. What they did is, first, you have initially your S1 was equal to 533.33. Okay? Now, this equation, can you tell me the equations they are writing here for S2 represent the total distance from the beginning of motion or just in phase 2? Who can tell me? If I write 80 times t minus 13.33, this will give me which distance?
The one in the second phase, or
very good. Or the one in the second phase. Why? Because first here, the distance from here to here, okay, is given by the velocity during this phase times delta t. What is delta t? Delta t is the time of this phase. And the time of this phase can be calculated by t1 minus 13.33. Why I should do minus 13.33? Because when I started phase 2 here, the time was not 0. Time was equal to 13.33. Okay. So when I want to replace in Vt prime, I should put instead of T prime T1 minus 13.33, because when I say Vt prime, I am counting T prime from here. Okay. So T prime is equal to the total time from here to here minus the time from here to here. Okay. So for phase 2, I cannot take the time from the origin, because if I start from the origin, I will consider also phase 1. No, my time for phase 2 is only starting from here. So it represents the total time minus the time of phase 1. This is why I have considered T1 minus 13.33. Now, because they didn't add plus 533.33, it means that for S2, they are considering that they are starting measuring S2 from here. Okay, so they changed the origin for position. Now, if you want to express S as function of the initial origin here, what should be S total? S total will be S2 plus 533.36. Okay, so if you want what they did here, they just calculated this is distance for phase 1, this is distance for only phase 2. Okay, and if you want to find, so here this distance represents only this part. Okay, and this distance represents only this part. If I want to find the total distance, I should write as total equal to 80 times T1 minus 33.33 plus 533.33. Okay, clear until here?
Yes.
Yes.
Okay. Now, to continue, okay, we want to find now equation of motion for B. Okay, so for B it is much simpler. Okay, for B, the distance traveled by B is equal to what? The velocity of B times T. Okay, for B, we don't have to divide into two phases, because for B, it's moving only at constant velocity from the beginning to end of motion. So we only have one equation for the distance traveled by B, which is 60 times the total time T1. Okay, so here now they choose in this problem to solve it using the second method. What was the second method we talked about? We said that when they meet each other, this means that, guys, please, حدا عم يحكي. Guys, حدا عم يحكي وعم يسمع صوته هون. Okay, so we have the total distance is S1 plus S2 plus S3. This part, S1 plus S2, okay, is the distance traveled by A, and S3 is the distance traveled by B. And we said when the two particles will meet each other, we have that total distance traveled by A plus distance traveled by B is equal to 6,000. So this is a first method to find the time when they meet each other. Okay? A second method is to say when they will meet, coordinate of A is equal to coordinate of B. If I choose the second method, what will be S of A? Who can tell me? Coordinate of A.
S1 plus S2.
Very good. S1 plus S2. And coordinate of B?
S3.
No. Why it's not S3? You should have the same origin for your coordinate. Okay? Look, S3 is counted from here. This is S3. This is S3. Okay? When I talk about a coordinate, I should take one origin. Where is my origin? My origin is here at the starting of motion. Okay? This is my origin. So the coordinate of B will represent this. This is the coordinate of B. This part. So the coordinate of B, if you want, is 6,000. The total distance minus what? Minus S3. Okay? Because we know that the distance from the origin to initial position of B is what? This is 6,000. And coordinate of B from the origin is the distance from here to this point. Okay? So this is the distance from origin to point B. So if I want to find this coordinate, I should do 6,000 minus what? Minus this distance, which is S3. So coordinate of B is 6,000 minus S3. And I should put SA equals to SB, I get the time. I will go back to the same equation at the end. Because if you look here, if you go down, okay, if you take S3 to the other side, what do you obtain? You obtain S1 plus S2 equals to 6,000 minus S3. What is S1 plus S2? This is coordinate of A. And what is 6,000 minus S3? This is coordinate of B. Okay? Any question on this problem? So can we move to another one? Okay. So let's start another problem. Now, just before they asked what is the distance traveled by B, so all I have to do is S1 plus S2. Okay. Now, another problem. When a particle is projected vertically upward with an initial velocity of v0, it will experience an acceleration A equals to minus g plus kv squared, where g is the acceleration due to gravity. Now k is a constant and v is the velocity of the particle. Determine the maximum height reached by the particle. So first, in any problem like this, I will look at the relation I have. What is the relation I have? A equals to minus g plus kv squared. So in this relation, A is function of velocity, okay? And I want to find what? I want to find position. I want to find maximum height, okay? So to find the maximum height, I should find a relation between acceleration, velocity, and position. So what is the differential equation involving A, V, and S? It's A ds equals to V dV, okay? So now, to find the position, since A is given function of velocity, I will take A to the other side. This is called separation of variables, okay? When I do separation of variables, I will have from this side only variable V, and from this side I will have variable position S. Now I will integrate. I will integrate for position from 0 to S, and for velocity from V0 to V, okay? Now, I want to find the maximum height. At maximum height, what will be the velocity? Who can tell me? What will be the velocity at maximum height?
Zero.
Zero. Very good. At maximum height, yes. At maximum height, the velocity is equal to 0. So now I will integrate from 0 to S and from V0 to 0. Okay? So here the integration is not complex because I have, this is, if I call this function u, the u prime will be plus 2 kv. Okay? And already I have v here. So all I have to do is to add the constant. So I multiply by 2k and divide by 2k. So I can integrate in a simple way. And don't worry about integrations. You will not have complex integral to do. Okay? So just the simple one. So now, when I do the integration, I can find S function of V0, okay, and V. And for S maximum will correspond to V equals to 0. So if I replace V by 0, I get the maximum height. Okay? So this is a relatively simple problem. Let's move to another one. Okay. So Ball A is thrown vertically upward with a velocity of v0. Ball B is thrown upwards from the same point with the same velocity t seconds later. Determine the elapsed time t for the instant ball A is thrown to when the two balls will pass each other, and find the velocity of each ball at this instant. Okay, so here in this problem we have two particles, and these two particles are launched from the same position but at different timing. Okay, so first I will A will move upward, and after t seconds B will move at the same initial velocity v0. Okay, so because I launched A before B, so A will go up and then go down, while B will still going upward. So when they meet together, A will be going downward, while B will be going upward. And the question is to find what is the time where the two balls will meet each other. Okay, so we will find the time where they will meet and the velocity of the two balls at the instant they meet each other. Okay, so in such a problem, what is the methodology? First, I will find the equation of motion for A and for B. Okay, and once I find equation y of A and y of B, I will say that when they will meet each other, y of A will be equal to y of B. Okay, so I can find at this time what will be the time where they will meet each other. Okay, and when they will meet each other, can you tell me how will be the magnitude of their velocities? Who can tell me what will be the relation between their velocities when they meet each other?
They are equal and opposite.
Very good. So we can verify that they will be equal and opposite. Okay. So now let's write the coordinates of each. Yes.
This y equal.
Y equal, because we will see after from work and energy. Okay, you will understand this in work and energy, because here in case of projectile motion, the particle is moving only under the effect of what? Of its weight. Okay, and in this case this force is conservative. So if you studied chapter 14, you will understand that I will not lose energy. This is why if I go through the same point, I should go through this point with the same energy state. Okay, so for particle A, when it will reach this position, it has kinetic energy and potential energy. Okay, and also for particle B, when it will reach this position, its total energy is divided into gravitational and kinetic. Now both have same gravitational energy because they are at the same height. And due to conservation of energy, if I reach a same position, I will reach it with same energy because I don't lose energy. This is why the kinetic energy at this position will be equal to the kinetic energy at this position. So the magnitude of velocity is the same, but the direction is opposite because A is going downward and B is going up.
Okay, thank you, Miss. Thank you.
Welcome. So now let's put the equation of motion for A and B. Okay, all I should pay attention for here is that the origin of time is different for A and B. Okay, because A started motion from the beginning, from t equals 0, while B started motion after a certain elapsed time. Okay, so here for the notation, just for the notation, pay attention. In general, we take as t as a variable, t is time, but here they considered that t is the elapsed time between the two balls. So if you want here, t is delta t. Okay, and because they choose to name delta t, so the time will be named another. So they will name time t prime. Okay, so t prime is the total time from beginning, and t represents the elapsed time between launching A and launching B. Okay, so now when I start by A, I don't have a problem because I launched A at t equals 0. So I can directly use the projectile equation for A. What is the projectile equation for A? It's SA equals to SA0 plus VA0 times TA plus half A TA squared. And TA here is what? It's T prime, because I'm starting from 0. Okay? And the acceleration is minus G. Since it's a projectile motion, the particle is only moving under the effect of its weight. And the initial velocity is V0. So this is my first equation as function of time. Okay? And I am interested in finding the time when the two particles will meet each other. When the two particles will meet each other, they will meet at a distance h. So SA will be equal to h. Okay? So this is equation number 1. Just sorry, 1 second. الو بحكيك بعدين. منيح. Okay, so here we have, this is equation for first particle A. Now I need to find another equation for B and said that SA is equal to SB. Okay, now the problem for B is that when B started motion, the time was not 0. So what should I do? Instead of putting T prime in the equation of B, what should I put? Can you tell me?
T plus delta T.
T plus delta T or T prime minus delta T?
T prime minus.
Prime minus delta.
Minus. Why minus? Because look at this example. If I launched A at t equals 0 and I launched B at t equals to 2 seconds, okay? When t becomes equal to 10 seconds, for example, the total time for motion of A will be 10 seconds, while the time of motion of B will be what? 10 minus 2, 8 seconds. 8.
12.
No, not 12,
8.
8. Why? Because when B started, already what was the time? 2 seconds. Okay? So when the time becomes 10 seconds, so B has moved during 8 seconds, which is 10 minus 2. Okay? Because A was launched before, this means that the time of motion of A is higher than the time of motion of B. Okay? So if the time for A is T prime, then the time for B will be T prime minus delta T. While if I consider the origin of time at B, if the time for B is T, for example, then the time for A will be T plus delta T. Okay? Is this idea clear?
Yes.
Okay. So now I can write the equation of B. Just before moving to B, if we want to write the expression of velocity, we can just apply the equation for constant acceleration. So VA is equal to VA0, which is V0, plus constant acceleration of A times T of A. And the constant of acceleration of A is minus G. Okay? So I get that VA is V0 minus GT prime. Now we can move to B. And as we said for B, we will consider the difference of time, because what is TB? TB is T prime minus T. Okay, so it's the same form of the equation, but I replace T by T prime minus T. So for S of B, I will have 0 plus V0 T prime minus T minus half G times T prime minus T squared. And when the two particles A and B will meet each other, I have that H will be equal to V0 times T prime minus T minus G over 2 T prime minus T squared. And now I put that SA equals SB, I can find a relation between T prime and T. Okay, so that's it. And for the velocity, also for the time, I should pay attention to put V0 plus minus G times T prime minus T. So once I get the value of T from SA equals to SB, I can replace in the expression of VB and VA and get the velocity. And you can see that when I replace T prime by its value, I will see that VA and VB will be equal in magnitude but opposite in direction. Okay? Any question?
Can you please scroll up just 1 second?
Yes. So first, yes, tell me.
Okay, thank you. لا ماشي.
So what they did, they said solving 1 equals to 3. So you put SA equals to SB. So you get T prime, okay? You get the time where they will meet each other, function of the elapsed time T, okay? And once you find T prime, you replace back in the equation of velocities. So you can get the velocity at point A and B function of the elapsed time T. Okay? So let us move to another problem. As a body is projected to a high altitude above the Earth's surface, the variation of the acceleration of gravity with respect to altitude must be taken into account. Neglecting air resistance, this acceleration is determined from the formula A equals to minus G0 times R squared over R plus Y squared, where G0 is the constant gravitational acceleration at sea level, R is the radius of the Earth, and the positive direction is measured upward. If G0 is 9.81 meter per second square and the radius of the Earth is 6,356 kilometers, determine the minimum initial velocity at which a projectile should be shot vertically from the Earth's surface so that it does not fall back to the Earth. Okay. First, here they gave us a hint, but we will try to think without the hint. Okay? What they did is they gave us acceleration function of position. Okay? And they want us to find what should be the minimum initial velocity so that the projectile will not come back to Earth. What does this mean? If the projectile will not come back to Earth, so it will never reach a velocity of 0. Why? Because once it will reach a velocity of 0, it will go back down to the Earth. Okay? So this means that V equals 0 should be reached only at infinity. So it will never be reached in this case. Okay? So when they said, I don't want the projectile to come back to the Earth, this means that V becomes 0 at infinity. So this is the condition in your problem. Now, you have A is given function of what? Okay? You have A function of Y, and you want to find velocity. So you should start from the relation between acceleration, velocity, and position, which is V dV equals to A dy. And then it will be very simple. It's very similar to the other example. So I do the integration, and also here it's a simple integration. So I can get a V function of Y, and now I can apply my boundary condition. My boundary condition is that when V is equal to 0, Y is equal to infinity. Therefore, I can get what should be my initial velocity, V0. So when you solve, you get that the initial launching velocity V0 should be equal to radical 2 G0R in order for the particle to not come back to the Earth.
Doctor,
Just man.
yes.
Yes.
Here we say that y goes to infinity, but
Yes.
here in fact, when this ball gets outside the Earth gravitational field, y is
Yeah.
not 0. Y is not infinite. Y has a value. So
Yes, but
why didn't
look,
we use this value?
no, because even if it's
You know,
going out,
the moment when the ball gets outside this gravitational field, it will not get back to Earth.
yes, but it's very the gravitational field is limited. You mean that the gravitational field is limited to a certain distance?
Yes.
In general here, if they give you the distance where it's limited, you can put it. But if they don't give you this information, so you will assume that the equation they give you is applicable because they didn't tell you that you have a limit for this equation. So I know what you mean, and maybe in real case they can tell you, no, this acceleration is limited to y, for example, of a certain value. But because here they gave you this formula without any limit, so you cannot know this. Okay, so you will say that I will apply this formula as it is, and I will consider that it can still be applicable at any distance from the Earth.
Okay.
Okay. Any question? Any other question?
بس ما كتير فهمت ليش لما y goes to infinity v is 0.
Okay.
مش إنه acceleration تبع الأرض إنه حتكون 0.
Okay.
إنه لو
Because
كنت
look, if you launch a particle, if you wanted to go back to you, it should reach a maximum height and then go downward. Yes or not?
yes, so v is gonna be
Okay.
0 before going down.
Yeah. Yes. Before going down, v should be 0. Now, if there is a position where v becomes 0, so the particle will go down. I don't want it to go down, so it should not reach a certain position. If you want a position with a number, with a limited number, where it will reach 0. So it will never reach 0 if you put the condition v equals 0 only at infinity. Okay, so it will keep going until infinity, and infinity is not a number, so you cannot reach
okay,
infinity. Okay.
Okay.
Okay, very good. So let us move to another example. So, starting from rest at s equals 0, a boat is traveling in a straight line with an acceleration as shown in the graph. Determine the boat's speed for different positions S4, S5, and S6. So here we have a graph, and we want to find the corresponding velocity at different positions. Okay, first let's locate S4. Okay, for S4 is equal to 40, so it's in the first phase because S1 is 50, so S4 is somewhere here. Okay, so S4 is somewhere here, so S4 is in the first phase. Okay, S5 is in the second phase because S2 is equal to 150, so S5 is somewhere here. S5 is somewhere here, and S6 somewhere here. Okay, so S4, S5, S6 are different points in different phases. So to be able to find the speed in these points, I should get the equation of velocity in these different phases. I will start by phase 1. Okay, for phase 1, I have constant acceleration, and because I have constant acceleration, so I can directly apply the relation between acceleration, velocity, and position for constant acceleration, which is what? V square final minus V square initial equals to 2a delta s. Okay, so starting for point 4, I know the initial condition, because at the beginning of the phase here, what was the condition? At the beginning of phase 1, it's starting from rest. Okay, so v here is 0, so I know the velocity at this point. I can get the velocity at any point in phase 1 by saying that, for example, at point 4, I can say that v4 square minus 0 square equals to 2 times acceleration in phase 1, and it's given, it's constant, equal to 2 times delta s, which is s4 minus s0. Okay, so the only unknown here is v at point 4. I get v at point 4. It's fine for first phase. Now for the second phase, my problem for the second phase is that I don't know the boundary condition for this phase. So what should I do? Where is the boundary condition for phase 2? This is here at this location. Okay, at this location I have start of phase 2. So to be able to find equations for phase 2, I should determine what are the conditions at this point. And to get the conditions at this point, can you tell me how can I do it? How can I get conditions at this point?
The end of the first phase.
Very good. The end of the first phase. So to be able to find conditions at this point, I will use equation of phase 1. Okay? So from using the equation of phase 1, I can find the velocity at point S1. So V1 square minus 0 square is equal to 2 times A1 times S1 minus 0. So I get V at S1. Once I get velocity at 1, now I can work in the second phase. Okay? Now I am interested in particular in point S5 here. At this point, so also here for the second phase, because A2 is constant, I can apply the relation that velocity of 0.5 square minus velocity at 0.4 square equals to 2A2 times delta S, where delta S is S5 minus S1. And from this relation, I can get velocity at 0.5. Okay, so I am done with velocity at 5. Now I will move to the last point, which is S6. Now for S6, it's a little bit more complex because A is variable. So please pay attention. Because in the third phase, A is variable, I cannot use the relation V square final minus V square initial equal to 2A delta S. What should I do in the third phase?
Integration.
Very good, integration. So the first step to be able to do integration is to find a function of what?
S.
Function of S. So to find a function of S, all I have to do is to consider this line. It's a straight line and it has a negative slope. So to find the equation for A, all I have to do is to consider 2 points. Okay? I have 2 points characteristic of this phase. This is the first point, and this is the second point. Okay? For the first
Why do we
point,
need the equation of this line? We can find the area without
yes, of
without
course.
finding it.
Yes, of course. You have 2 methods. You can work as a geometrical method, or you can work as analytical method. Okay? If you want to use the area method, okay, I will do both for you. So let us first do the analytical method, and the second method will be the area one. So first, if you want to use the analytical method, we should find the
Doctor, I have a
equation.
question, please.
Yes, yes.
I have a question. What if we have a more difficult curve, like x cubed, for example? We directly use the integration method.
Yes, yes, of course. If it's a complex function, it's not easy. You cannot find the area. If you should do integration. Okay. So now, to find the equation of this line, okay, I have 2 points. The coordinate of this point are S2, A2, and the coordinate of this point are S3, 0. Okay. Once I have the coordinates of 2 points, I can find the equation of my line. So I get a function of S. Okay. So now I can say that A ds equals to V dv. I am particularly interested in position S6. So inside of S, I integrate from S2 to S6 ds, A ds equal to integral from V2 to V6 V dv. Okay? For integral V dv, it's very simple. It's V6 square over 2 minus V2 square over 2 equals to, from the other side, I have integral of a linear function times ds. So I integrate the linear function, I get a second degree, and I can calculate the value of V6. But also, to find V6, I should calculate what? I should calculate V2. And to obtain V2, as I did before, I use the equations of phase 2 to get velocity of 2. Then I use it to find velocity at point 6. Is the analytical method clear, or do you want me to repeat something?
Sorry, miss, can you repeat, please?
Okay, I will. Let us see the equation to facilitate for you. Okay. Here they did it directly in one step. Okay, this is why it seems a little bit complex, the formula. but the procedure is really simple. Okay, this is the integral part. It's the integration of a ds. Okay, we said that during phase 3, a is varying in a linear way. Okay, so when you write VdV equals to a ds, a is not constant. So to be able to do the integration, you should find a as a function of s. To find a as a function of s, because it's a straight line, all you need is the coordinates of 2 points. And you have these 2 points of known coordinates. For this one, it's s2, a2. And for this one, it's s3, 0, because you don't have acceleration. Okay? Once you get the coordinates of the 2 points, then you can find the equation. It's a linear equation, a function of s. Okay? Once you find this equation, so for example, let's say it's any equation. For example, 3 minus 3s. Example, it's not the case here. Okay? Now, you have your differential equation, VdV equals to a ds. What do? You replace a by the function as function of s. So for example, 3 minus 3s as example. And then you integrate. You integrate from both sides. From the side of v, you want to find velocity at this point. So you integrate from v2 to v6. Okay? Equals to, from the other side, I have integral a ds. So I integrate from s2 to s6 of my function a, which we said, for example, 3 minus 3s times ds. Since you have the function a function of s, you can perform the integration. Because you have a linear equation, when you do integral, you will get a second degree equation, and then function of s. Okay, and then you replace by s6 and s2, so you can find velocity at point 6. But to be able to calculate it, you need to find velocity at point 2. To calculate velocity at point 2 is at the end of phase 2. So you can apply the relation in phase 2 for velocity to get v2. Once you get v2, you replace in your equation, you get v6. Is it clearer now? For the one who asked me, is it clear? Any other question? Okay, so if you want now, let us try to do the second method your friend proposed. Your friend is saying, because I have v ads equal vdv, I can use the area method. So I can use a geometric method. Okay, to understand more how to do it, first let us repeat the analysis. Okay, I will remove everything here. Okay, let's consider that you want to use geometrical method. For example, if I start by the geometrical method for phase 1, okay, I am interested in finding the velocity at S4 here, for example. Okay, what is the area method? The area method tells me that integral ADS represents what? Integral ADS represents the area under the curve, this area, for example. So when I say V1 square over 2 minus V0 square over 2 is equal to integral ADS. Integral ADS is this area, okay? So instead of doing integration, I can say that integral ADS is directly A1 times A1, which is this distance, times S4 minus 0, okay? Because the distance here, from here to here is S4. So this distance is from 0 to S4 is equal to S4. So the area of this rectangle is A1 times S4. So I can directly say that V4 square minus V0 square over 2 equals to A1 times S4. This is the area method. Now, if we want to apply it for the third phase, it's a little bit more complex. Okay, why? Because I know the velocity at 2. Okay, I know the velocity at point 2 here. So what will be the area here? I have the area of a trapezoid. Okay, so you can say that velocity at point 6 square minus velocity at point 2 square over 2 is equal to the area under the curve, which is the area of a trapezoid. And you can find it by geometrical calculation directly. Okay? But in this case, the problem is to calculate this length here. And to calculate this length, who can tell me what you can do? How to geometrically calculate this length? I can use which theorem? Are you hearing me?
Doctor, they are writing on the chat. So,
Oh, they are writing on the chat.
yes.
Okay. Because I don't know why I'm not able to say it now.
This is Thales.
Yes. We will use Taylor's theorem. We can find this length. So we do this distance over A2 is equal to this distance, which is S3 minus S6, over this distance, which is S3 minus S2. Therefore, we can calculate this length and we can get the area. And we can use in this way the area method to calculate the velocity. Any question?
Can you repeat, please?
Okay. The area method only.
The last thing you said about the length.
Okay. To be able to calculate the trapezoid area here, what is the trapezoid area? It's the small base times big base times height over 2. Okay? So to be able to calculate this area, you need to find this distance. To find this distance, you can use two methods, or similar triangles, or Thales theorem, Théorème de Thalès. Okay? So if you use Thalès, you have that this distance from here to here, which is S3, the whole one, minus S6, okay? So this distance over this distance, which is S3 minus S2, equals to the length here over the length here, which is A2. So in this way, your only unknown is this distance. You can find it from Thalès. Okay?
Okay, thank you.
Any other question? Okay. So can we continue, or at what time is your next session? Can we continue and do more problems, or you prefer to stop here?
Yes, you can continue.
Okay.
But not for too long, please. إنه شيء 12:30.
Okay. Okay. Okay, problem 6. So a boy at O throws a ball in the air with a speed v0 at an angle theta 1. If he then throws another ball at the same speed v0 at an angle theta 2, determine the time between the throws so the balls collide in mid-air at point B. Okay? So what we have here, we have two balls that are launched at different times and at different angles. Okay? So what we want to find is to find what is the elapsed time delta t between throwing A and throwing B if we know that the two particles will collide at B. Okay? So here, if you want, you will solve your problem function of x and y. I don't know if they gave you x and y. No. Okay. So here we know that they will meet at B. So when they meet at B, we can say what? What is the condition to meet at B? They should have same x and same y. Okay? So when they meet at B, x of ball A is equal to x of ball B. and y of ball A is equal to y of ball B. Okay? And what we know about the two particles is that they are launched with the same initial velocity, but at different angles, theta 1, theta 2, and at different times, because they said that first we launched A and then we launched B after. Okay, so here if you say that, for example, the time at A, let's say, is t, then the time for B will be t minus delta t. Or if you take the origin of time at B, so you will say that for particle B the time is t, and for the other the time is t minus delta t, t plus delta t. Okay, so it's the same concept as we have seen before. So first I will write two equations, one for ball 1 and one for ball 2. Okay, so first for ball 1, which is launched at theta 1, the equation is x equal to v0 cosine theta 1 times t. Okay, so you have for t, for this ball, because it's launched after ball 2, because it's launched before ball 2, so the time for ball 1 is t. Okay, while the time for ball 2 is t minus delta t. Okay, now what they did here, they directly said when they will meet each other, x of A, or if you want, let's name them particle A, particle 1, particle 2, because B is a point on the figure. So x of particle 1 should be equal to x of particle 2 when they reach point B. So x is equal to x of particle 1 can be calculated from v0 cosine theta 1. Why v0 cosine theta 1 t? Because you know, for projectile motion, how you get the equation? For projectile motion along x direction, the velocity is constant. Okay, so the equation for x will be what? Will be v0x times t plus x0. But because they are launched from the origin, so x0 is 0. So for particle 1, the coordinate is v0 cosine theta 1. Why we did cosine theta 1? Because we are projecting on x times the time t for ball 1 equals to, for the second ball, it's the same equation, but the difference is that for theta, it's theta 2, and for the time, it's t minus delta t, because particle 2 is launched after particle 1. So this is my first relation. My first relation is x of particle 1 equals to x of particle 2. Now, the second relation is y of particle 1 equals to y of particle 2. So for y, what is the equation? The equation is minus half gt squared plus v0y times t plus y0. And also y0 is 0 because it's starting from the origin. Okay? And v0y, I project v0 on y, so I multiply by sine theta. So the equation for y is minus g over 2t squared plus v0 sine theta 1 times t. This is y of particle 1. It should be equal to y of particle 2 when they meet. So what is the equation of particle 2? It's similar to the equation of particle 1, but instead of time t, we put t minus delta t, and instead of theta 1, we put theta 2. Okay, so we end up here with the following two equations. So we can get, if you want, what is the condition so that the two particles will meet. Okay, so by eliminating
Delta t is the time between what and what?
Delta t is the time between launching particle 1 and launching particle 2. Okay, so here what is our unknown? We have here two unknowns. You can tell me what are the two unknowns? The two unknowns are what? Delta t first, which is the elapsed time between launching A and B. And the second unknown is the time where they will meet each other. Okay, so here you have
Yes,
two
thank you.
equations. Yes. So you have two equations with two unknowns, t and delta t, okay? By eliminating t between the two, you get the elapsed time delta t, which is the time between launching particle A, and particle 1 and launching particle 2. So this time, delta t, will be function of the initial speed v0 and the angles theta 1 and theta 2. Okay? Any question?
No.
Okay.
Doctora, for Thursday,
Yes.
we use the same username and password.
No, each time I will send you a link.
Okay, it will be the same time.
Yes.
And for the task that we
Yes.
will be doing, it will be written or multiple choice.
Multiple choice.
Can we make it written?
Look, believe me, it's very hard to do it written online. It's not feasible because we are already discussing this with responsible in AUB and with other teachers, and all are saying that it's not very practical to do written exams online.
Because if we have calculation mistakes or
Look, I will do my
like
best
this,
so that
we lose the whole grade of the
don't.
question if
First-
it is
first-
multiple choice.
Yes,
It is
first the
written.
level will not be very hard, okay? And you will not have longer questions. So I will do it in a way that will minimize calculation errors. In addition, I will do several tests for you. So I will do drop the lowest, I will do raise. So I will do everything to help you. So don't worry.
How many tests will we make?
Not less than 3, maybe 4. And I will drop the 2 lowest or 1 lowest, depending. So my average will be 78, whatever you do, okay? So if your average is below 78, I will raise up to 78. So if it was hard,
the
yes.
first test, when will it be the first test?
We set the date for the first test. I think April 16.
Yes.
Yeah, April 16th. Doctor, will it be بكرة or in the afternoon? I really need to know.
We didn't set the date yet, so as you like. I don't mind, as you like.
Okay, just can we do it before 5, please?
Okay. Also, we can discuss it on the group, and yes, I don't mind. So before 5. So 3, for example. If 3 is fine for all, we can do it as 3.
I have no problem.
Okay.
Thank you.
So every week we will have a test?
No, not every week we'll have a test. But look, for the first test, I give you time. I give you a lot of time because I know it's new for you, and you didn't start studying directly from beginning of vacation. So this is why I put it at April 16th. But if you prefer to do it before, I don't mind. So we can do it earlier, then we can proceed for other tests.
Miss, April 16 is good.
Okay, but look, after April 16, we cannot wait a lot to do another test. Or maybe I might do 2 tests on the same subject, so to give you more chance to get a good grade. So I might prepare 2 tests on 12, 13, 14, for example. You do a first test, we see how is the average, if it's fine or not. So I can or do raise or do more tests in order to drop the lowest.
Can't we do short quizzes?
We might do short quizzes after, yes, why not? On each chapter, maybe, yes, it might be. So after we do the first exam, we can start to do a small exam on each chapter if you want.
فينا on each 2 chapters أو هيك لأن عنا كمان غير courses عم بيعملوا هيك فنلحق ندرس.
طب okay, هلا let's for exam 1 it's fine April 16 or can we do it before?
16
No, April 16 is fine.
So for April 16 it's 12, 13 and 14, okay? Chapters 12, 13 and 14. And
okay.
Next, for Thursday, I should continue course material, okay? And we can organize an extra session at the time you want to continue review problem. So
On
choose
Thursday,
yes.
on Thursday, we will have the second part of chapter 16. We'll continue.
No, I will start 16 from the beginning because it seems that you find it difficult in PPT and PowerPoint.
Yeah, please, Professor.
Yeah, I will repeat 16 from the beginning, so you don't have to know anything before.
Okay, thank you.
Welcome.
Thank you.
And in case for chapter 15, you have questions, you can ask them to me, okay? But it seems that for chapter 15, it worked with you the PowerPoint.
Yes.
Okay. Yes, 16 is hard, I know, so I will repeat.
Thank you, Doctor.
And now, if you want on the group, let's vote for an extra session. You prefer it to be Saturday or Monday? So I will put several options for you and choose one of the options.
Can we make it on Thursday or Tuesday? Like
yes,
we make a long
time?
We make a long session.
We'll vote.
No, we will have a long session lectures, but we need extra lectures because we have a lot. If you want me to do for you all review problems, we need a lot of extra time. Because in general, I am supposed only to teach you the course material and you do problems in recitation, not with me. But I want to help you. So if we want to solve together problems, we need extra sessions.
بس فينا نعملهم قبل بجمعة من الفحص أو هيك إنه بنجبوا الجمعتين extra sessions.
فينا بس I should start during the sessions start chapter 16 because we still have 16, 17.
فينا نبلشوا قبل chapter 16 إنه priority الماتيريال الجديد وهوليك extras إنه review problem.
صح ساعة اللي بدكم extra I don't mind at the time you want. It can be if you prefer to have it on Monday or Friday, anytime. So we can now decide on a time for next week or for this week if you want. For example, tomorrow we can do a session if you want afternoon.
Tomorrow is a holiday. I don't know if we can do classes.
Okay, so let us decide after for the extra. So now we will meet Thursday. And we decide on the group for an extra session to continue review problems, okay?
Thank you, Miss.
Welcome. Okay, I will stop the recording and send you the link. Bye-bye.